Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on multiple access. This video probably will interest the younger generation. This video, I'm going to discuss on our mobile phone. Okay, I'm going to discuss our mobile, how they actually evolve from 1G to 5G with different multiple access techniques adopt. Okay, which means that our mobile phone actually move from first generation all the way to fifth generation. And in fact, they actually also apply different multiple access so that they are able to move from 1G to 5G. So this video, I'm going to discuss why they need to change the multiple access in order to serve us better. Okay, so this will be the objective of this multiple access. This is my email. If you have any question regards on today's discussion, please drop me an email. Before I continue, I'd like to urge you guys again to support this channel by pressing the like and also the subscribe button. Please also turn on your notification bell in order to receive more information from this channel. Guys, actually, this topic is actually request from you guys either through comments or email. Okay, so basically, I have one video which is also on multiple access. Okay, I guess that particular video is probably having the most viewer. Okay, so basically, you guys actually asked me to describe the multiple access with the example of mobile phone. Okay, so therefore, I have decided to do this discussion, okay, how the mobile actually evolved from 1G to 5G by using the different multiple access that we also discussed earlier on. Okay, so I'm going to put that particular link on the multiple access under the description. You can take a look on that particular video in order to understand the discussion on multiple access. Okay, firstly, let's define why we need to have multiple access. Okay, as you guys probably know that through the earlier on discussion, okay, multiple access is how can we actually share a common resource with many users or maybe as many users as possible. Okay, so the definition on multiple access is basically in a communication system. Okay, they are designed to support many users, or in fact, we want to support as many users as possible in a given time period. Okay, so therefore, a well-defined scheme must be devised to accommodate all the users in an efficient and cost-effective way. Okay, so the key thing over here, you can see that we want to support as many users as possible in that particular given time. Okay, and the scheme, they must be efficient and they must be cost effective. Okay, several techniques have been developed, and the more common ones are FDMA, frequency division multiple access, TDMA, time division multiple access, code division multiple access, okay, which is also known as CDMA, orthogonal frequency division multiple access, and last but not least, spatial division multiple access. Okay, so these are the 5 common multiple access, and in fact, they are actually related from our mobile phone from 1G, 2G, 3G, 4G, and 5G, which I'm going to further discuss later on. Okay, so this is how our mobile phone actually moved from 1G all the way to 5G. I actually born, I won't say that I born on the 1G era, definitely it's not true. Okay, so I was actually in my secondary school, I'm not sure whether you guys have heard about this called pager. Okay, so in my secondary school days, probably is the era of pager that is actually born before the cellular phone are actually all born. Okay, so basically, but now this video, we are going to concentrate just on cellular. So 1G is born around 1980. Okay, so this is a picture, how does a 1G mobile phone actually look like? Okay, in reality, at that time, there is probably don't have such thing called 1G. Basically, the mobile phone for so-called this 1G is a very big, okay, look like almost like a brick. Okay, it actually can hit your head, you will feel very painful. Okay, so this is what I remember. It's a very big, bulky brick mobile phone, quite heavy also. I think technically it's about maybe 2 kg, something like that, 1 point something kg. Okay, so this is how does the 1G mobile phone look like. Okay, at that time, I think Motorola is the maker of this 1G mobile phone. Okay, so Motorola actually dominate on the so-called pager. They also move into this cellular. Okay, also I think Ericsson actually is in between 1G and 2G. So Ericsson also born making on this cellular phone also. So 2G, okay, basically start to belongs to the world of Nokia. Nokia actually start to dominate in the 2G market. Okay, so 2G started around 1992. And of course, in between 2G and 3G, there's some company called BlackBerry. I'm not sure whether you still remember. Okay, BlackBerry actually allow us to read emails, for example. Okay, there is it's almost very difficult to surf internet at that time. So BlackBerry is actually in between 2G and 3G. They actually allow us to read email, etc. So after that, when 3G is born, it belongs to the era of Apple. Okay, so basically Apple actually start off this 3G. Okay, so 3G, okay, I will mention a little bit more on 3G. So 3G will probably started the Apple domination on 3G. So Apple, in fact, also dominate in 4G and 5G. But there's also another key player, which is Samsung, actually come into the picture. Okay, so Samsung come in between 3G, and they also try to dominate in 4G and 5G, which I will further discuss what are the key difference between 1G, 2G, 3G, 4G, and 5G based on their multiple access. Okay, so let's come to the 1G. Okay, 1G actually adopt this frequency division multiple access. Okay, so later on I will describe what is frequency division multiple access. Okay, 1G is the first generation of wireless cellular technology. Okay, so this mobile phone, okay, basically you don't have a hard physical wire. And in fact, it's the first generation of wireless cellular technology at that particular time. Okay, 1G at that time, they only purely support voice call only, okay, which means that you can only support through our normal calling features, okay, nothing else on exciting features on mobile phone at that time. They purely are used for to call someone, that's all. Okay, 1G at that time is using analog technology, okay, so the signal, which means that our voice, in nature, our voice are all analog signal. So basically, they actually send this analog signal to another mobile phone. Okay, so this is what I mean. Okay, so 1G at that time purely support on analog signal only, and it had a poor battery life. I think the battery life typically can last about maybe 2 or 3 hours. Voice quality is very, very bad. Okay, sometimes you can't really hear it. Therefore, you imagine you can say, hello, hello, hey, hi, hello, huh? Can you hear me? Okay, so basically this 1G era, okay, they have a very poor voice quality, very little secure, okay, which means that, okay, your signal basically sent out by 1G, okay, someone, if they really want to pick up your signal, they can actually pick up your signal, okay, because at that time, the focus is basically to come up the first wireless cellular technology, not so much focus on security, and they are also very prone to drop call, okay, which means that your line will suddenly cease and you need to re-establish the call again. So basically, these are some of the limitation on 1G. Okay, the maximum speed of 1G, okay, is about 2.4 kilobits per second. Okay, so basically, this just want to let you understand, okay, how fast first generation can be. So typically, it's about 2.4 kilobits per second. If let's say we can really measure in terms of the bit rate here. Okay, so as I shared with you earlier on, basically 1G actually utilize this frequency division multiple access. Okay, so what is FDMA? It's basically each user is assigned one unique frequency for communication between the transmitter and receiver. Okay, so if you take a look on this diagram here, all the different colors means different user. Okay, at that 1G generation, okay, not many people actually own the mobile phone. Okay, I will say that at that time, only the very rich can own the mobile phone. So therefore, at that particular time, we can afford, okay, to give that particular user one frequency band. Okay, so basically, can you imagine every user, wow, can just occupy one resource block on the frequency spectrum. Okay, so basically that will be the era in the 1G generation. Okay, so if there are multiple transmitter and one receiver, okay, different transmitter will transmit by different frequency to the receiver. Okay, so next slides, I will give you a little bit more or some animation to understand this FDMA. Okay, so the wording all over here is basically based on the previous page. Okay, the key idea is to do a animation for you to understand FDMA. Okay, so basically, this is a base station. Okay, so basically from here you can see that this is frequency versus time. Okay, for example, first user talk to the base station. Okay, so you can see that the first user occupied frequency 1. Okay, and they actually occupy all the time. And then let's say there's another user 2 talking to the base station, okay, at different time. So basically you can see that user 2, again, they use another frequency. Okay, you can see that they use the frequency F2 to communicate with the base station. And let's say another user, which is F3, okay, you can see that basically another user, they actually use another frequency to talk to the base station. So in short, over here, the first generation, they actually assign a unique frequency to all the different users. And basically, this actually avoid so-called interference with each other. So every user are so-called assign a particular frequency to communicate with the base station so as to avoid interference. Okay, so over here, you can see that in the era of that particular 1G, we still can afford, okay, but now the issue come up on 2G, okay, because I can't add in more and more user, okay, because once you have these exciting features of having this wireless cellular, okay, more user want to come into this space, and this 1G, okay, the limitation is I can't put in any more user, okay, as I'm going to have more and more user in this base station, serving more and more user. So this become a big issue. Okay, so how they actually solve this? Basically, they solve this by using this 2G, okay, using this time division multiple access. Okay, so later on, I'm going to show it to you in a graphical way, okay, how this time division multiple access accommodate multiple user. Okay, as I shared with you earlier on 1G, okay, the limitation is I can't increase my frequency anymore. Okay, because for example, this frequency or this bandwidth is given for the mobile user. And therefore, once I finish assign the frequency to all the user, I can't accommodate more user into this space here. So therefore, for 2G, they actually adopt another method, which is called the time division multiple access. The key idea is to have more user. Okay, let's come to this 2G here. The cellular phone have major upgrade when the technology went from 1G to 2G. Okay, this leap took place in Finland, okay, in 1991 on GSM network and effectively took cellular phone from analog to digital communication. If 1G is still on analog, so basically when 2G or GSM take over the 1G, they basically transform from analog to digital communication. The 2G telephone technology introduced call and text. Okay, so if you still remember SMS, okay, basically this text encryption, okay, along with data service such as SMS, picture message, and MMS. Okay, so 2G bond, okay, if you still remember, the key idea of having 2G is basically we have this form which is called SMS. Okay, we send as data. Okay, so at that time, telco actually so-called limit the numbers of SMS we can send. And if we exceed this number of SMS, they will charge us separately. We can also send picture like MMS. Okay, at that time, it's still very expensive to send a picture. Okay, so basically this gives you the idea of 2G. They basically move from analog to digital because they need to, in the digital space, because we start to send digital data like SMS to our recipients. Okay, although 2G replaced 1G and is superseded by later technology, okay, it is still used around the world. Okay, although 2G seems like a very old technology, but in many areas, okay, maybe I would say that those not so developed countries, they actually still prefer to use 2G. Okay, the key idea why they want to use 2G is 2G can actually support a longer range. Okay, which means that, for example, in a rural area, okay, where there are not many users, for example, I may be considered to put 2G to serve all these users. Firstly, the cost is much more attractive. Secondly, 2G can have a longer range, which means that I can serve a bigger range. So therefore, this is the consideration for 2G. Typically, they use in a rural area which they accommodate more user. Okay, the maximum speed of 2G with General Packet Radio Service, which is called GPRS, is about 50 kilobits per second. Okay, the maximum theoretical speed is 384 kilobits per second. Okay, with this enhanced data rate for GSM evolution, or we call the H or H plus. Okay, for H plus, basically they can get up to 1.3 megabits per second. Okay, so this gives you some idea, okay, on the 2G mobile phone. Okay, so let me quickly explain what is time division multiple access. And also, okay, I'm going to so-called explain how this time division multiple access can utilize or maybe can afford to have more user here. Okay, each user is assigned unique time, but same frequency for communication between the transmitter and receiver. Okay, so if you still remember for FDMA, they probably occupy this whole frequency, okay, all the times, and there is only one user. But if you look at this TDMA, okay, because 1G, for example, you are not going to be on the phone 24/7. Okay, so once you are not using, you can actually use this, or you can actually release this frequency for someone to use. Okay, basically, this is the idea of TDMA. Okay, because we are not going to be on the mobile phone 24/7. Okay, so once we are not using, okay, we must be able to share this resource with another user. Okay, so let's take a look how TDMA actually accommodate more user. Okay, over here, you can again see different color. Okay, again, these are all different user. Can you see over here, early on for FDMA, I can only have one user. If you still remember, I only have one user. But for this TDMA, at this one frequency, I can have 1, 2, 3, 4, 5, 6. I can have 6 user now. Okay, so basically from here, you can imagine that at that particular frequency, okay, instead of having one user for FDMA, one shot, I have 6 user for TDMA. Okay, so this is the meaning. Okay, so basically, imagine over here another 6 user, 6 user, 6 user, 6 user, 6 user, and 6 user. But for FDMA, I probably can only have one user for here. 1, 2, 3, 4, 5, 6, 7. I probably have only 7 user. But with TDMA, it's basically 7 times 6, which is 42 user in the same space of time versus the frequency. Okay, so if there are multiple transmitter and one receiver, okay, different transmitter will transmit at different time to the receiver. As you can see over here, they basically take turn, okay, take turn to transmit. Okay, so basically they share not only on the, for example, if I'm going to have many user on different frequency, okay, besides sharing the frequency, okay, the user actually also share the time. Everybody take a unique time to transmit the signal. Okay, so basically this is the idea of TDMA. Okay, so now let me just use a graphical way for you to understand on TDMA. Okay, so at this particular example, I'm going to only explain at just one particular frequency. Okay, for example, when user want to communicate to the base station, okay, basically they are assigned to a time slot. They basically communicate to the base station. After that, they actually stop the communication and pass the baton to user 2. So once the user 2 has the so-called authority to transmit the message at this particular time slot, they will send all the message or as much message as possible at this given time slot to the base station. After that, once its time is up, they will stop and they will pass the baton to user 3. And basically, again, the user 3 has this time slot to send a message to the base station. They will try to send as much as possible message to the base station. And once the time is up, okay, for example, for this case, they can pass back the baton back to user 1 to communicate with the base station. Okay, so this gives you some idea. Earlier on is basically for FDMA, okay, so basically all the user is actually using this unique frequency. So basically they just transmit, okay, without concern whether is it time for them to transmit. So because they are given the unique frequency, once it's their turn, they just transmit. But for this case here, you can see that they actually take turn to transmit. Okay, so this is what I mentioned earlier on. They go back all the way to user 1. Okay, let's quickly understand in terms of TDMA again. Time division multiple access is a channel access method for sharing medium network. Okay, so this is a keyword. It allows several users to share the same frequency channel by dividing the signal into different time slots. The user transmit in rapid succession, one after the other, each using its own time slot. Okay, this allows multiple stations to share the same transmission medium, okay, which, for example, the radio frequency channel, while using only a part of its channel capacity. Okay, because we are not going to use the mobile phone continuous 24/7. Okay, a lot of time we may not be using the mobile phone. Okay, so another key idea is, or maybe the key weakness of this TDMA is, for example, now if I have many message to send, okay, then I need to take a long time because I need to wait for my turn before I can send my data to the base station. I need to wait patiently, okay, until my turn, the next turn, before I can transmit again. Okay, but if I'm not using the mobile phone, I'm perfectly fine. But this method, TDMA, you can see that if I have lots of message to send to the base station, I may have some issue because I need to wait very patiently for my turn to transmit to the base station. Okay, so this is the limitation of TDMA if I have lots of message to send. Okay, next let's move to 3G. Okay, so 3G basically start another era of multiple access, which is code division multiple access. The introduction of 3G network in 1998 ushered in a faster data transmission speed, so you could see your cellular phone in more data demanding way, such as for video calling and mobile internet access. Okay, so basically early on 2G, I told you that it's the era of SMS. 3G probably is the start, so-called, to have mobile internet, and we also managed to have some video calling. Okay, at that time, honestly, 3G for video is still very lacking. Okay, so you guys are all now in 5G world. Okay, so basically it's much more easier to call a video call. But at that time, okay, it's basically the start, okay, that we can actually do a video conference, okay, using 3G. Okay, the term mobile broadband was first applied to 3G cellular technology. Okay, so basically they increase the bandwidth in order to send more data. So basically this is what it means. So basically at that time 2G is still very restricted in terms of bandwidth, but in 3G they actually increase their bandwidth. So therefore they use this mobile broadband. CDMA is a form of multiplexing which allow numerous signals to occupy a single transmission channel, optimize the use of available bandwidth. Okay, we come to this shortly, okay, on the next few slides. In fact, I have done something on CDMA. Okay, so I will put that particular video under the description. So take a look on this CDMA video in order to understand, okay, how does this CDMA actually accommodate multiple users. The maximum speed of 3G was around 2 megabits per second, okay, for non-moving. Okay, so for this CDMA, okay, the key concentrate is whether you are moving. Okay, so if you are moving, okay, you can see over here, your data rate actually reduced drastically. So if you are moving, for example, in a vehicle, okay, the data rate reduced to 384 kilobits per second. Okay, as some idea, okay, what is CDMA? Okay, each user is assigned one unique code. Okay, so every user are given one unique code for communication. Okay, and they actually occupy a wide bandwidth. Okay, users are identified by the base station, okay, by that particular unique code. Okay, so I have also explained on CDMA, okay, based on the multiple access. Okay, because of the constraint of time, I probably can't really explain on CDMA. Okay, I suggest you to look at that particular video on CDMA. Okay, but basically CDMA basically assign a unique code to all the user. So all the user has a unique code. The base station identify all the user based on the unique code that is given to them. So they actually will know that this message is from this mobile phone, for example. Okay, as I mentioned earlier on, I have done a video on CDMA and I have given an example, okay, how we can actually apply this CDMA to recover the original message. Okay, like what I mentioned, I have put the video link under the description. Take a look on that particular video, okay, in order to understand a little bit more on CDMA. Okay, let's come into 4G, okay, which is orthogonal frequency division multiple access. Okay, the fourth generation of network, okay, which was released in 2008. Okay, it support mobile web access like 3G does, and also gaming service. Okay, so 4G start another era where we can actually play games. HD, mobile TV, video conferencing, 3D TV, and other features that demand high speed. Okay, so after this 4G, it belongs to the world of, beside so-called mobile phone link to the cellular, okay, we have lots of other possibility things that can be able to link to our broadband. Okay, for example, our TV. Okay, nowadays the TV at our home don't really function as a TV. They can be a computer. They can also do a video conferencing, etc. Okay, so therefore this is the changing of this OFDMA. Okay, the maximum speed of a 4G network when the device is moving is 100 megabits per second. Okay, the key idea, you can see that the speed actually drastically increased from 3G to 4G. The emphasis of 4G is basically we start to send more and more data. For example, we want to have a video conference. Okay, therefore we need to have more data. So 4G actually support more data. Okay, so later on, I'm going to explain how can actually 4G support more data, okay, in a very simple example. Okay, the speed is 1 gigabits per second for a low mobility communication, okay, which means that you don't really move so much as compared to a car, for example. Okay, for example, when I actually walking, okay, I actually can more or less, you know that this is ideal, 1 gigabits per second. Okay, so they actually, telco can actually guarantee this 1 gigabits per second in the ideal world. Okay, most current cellular phone model actually support both 4G and 3G technology. Okay, so I think 3G, a lot of place they already start to sunset. Okay, so they start to have 4G, and now we actually going into the era of 5G. Next, okay, so this 4G they are using this orthogonal OFDMA. Okay, so basically this orthogonal frequency division multiplexing is actually used in 4G, or they actually call this LTE, long-term evolution cellular system. Okay, this OFDMA is a modulation method that divide a channel into multiple narrow orthogonal bands that are spaced so that they don't interfere with one another. Okay, so later on, I'm going to do a comparison between 2G, 3G, and 4G. This will give you a better understanding what is this OFDMA. Okay, so again, you can see that this is basically a frequency versus the time. You can see that at this particular space, they are actually supporting 3 users. Okay, again, later on, I will use another chart to explain to you the difference between 2G, 3G, and 4G. Okay, so let's start, okay, by doing a very quick comparison between 2G, 3G, and 4G. Okay, so this is the method, okay, which is using this FDMA. Okay, so basically this is the first generation of so-called 1G here. So basically, as I shared with you earlier on, if we are going to utilize this FDMA, okay, this frequency is actually all given to a particular user. So basically, the user actually will occupy this frequency is assigned to me. So basically, I will occupy this frequency all the time. And let's say if I'm not transmitting, it will become white. So it's a waste here. You can see that no one is actually transmitting. So user 2 again, okay, so this white means that he's actually not transmitting, and basically they only occupy this 4 resource here. And same for user 3, 4, 5, and 6. So you can see over here, they basically occupy a unique frequency. As I told you, this 1G, okay, I have some big issue because I can't increase my frequency anymore in order to accommodate more user. As I share with you, the 2G coming on board, okay, the one of the key thing they need to resolve is how to incorporate more user. Okay, over here, as I mentioned earlier on, the frequency or the frequency resource is actually a limited resource. I can't increase any more user. So therefore, they move into this TDMA. Okay, again, all these different color represent all the different user. Okay, from this picture here, you probably have 1, 2, 3, 4, 5, 6, 6 user. But in this TDMA, for example, this is user 1, user 2, 3, 4, 1, 2 again. So you can see that basically at the same frequency, instead of 1 user for FDMA, I actually can have 4 user. in this TDMA. So from here, the idea is basically you can see that this FDMA actually increase, using this TDMA, they actually increase the numbers of users. So therefore, for this 2G, more user can come on board on using this frequency spectrum. But I forgot to mention. Just assume that all the frequency band is the same. But the key idea is, for example, if I have a device that want to send a lot of message, you can see that, for example, this particular user, they has lots of message to send. You can see that they need to wait very patiently for the rest to send before it's done. Then he can send a message again. You need to wait again. So this become very so-called inefficient. They need to, if for any particular user that need to send lots of data, it become an issue because you need to wait for its turn before it can send the data. So this is why 4G is very effective. 4G know what you want to send. So once they know what you send, they actually allocate, not only on the time and frequency, they basically allocate here. So imagine this, for example, here. So this is one user, user 1, user 2, user 3, and user 4. Can you imagine this, for example, now I'm this user 4. Can you see that they basically assign 3 frequency resource, and I'm given this 1, 2, 3, 4, 5 time slot to receive my data. Not only, for example, for FDMA, let's say, I have this much resource. Can you imagine this resource? I need to queue up one whole long. But over here, I can simultaneously receive the same resource at different frequency. So which means that this is actually much more effective than FDMA because I can simultaneously receive 3 times as fast as FDMA. So can you imagine this? So if there's a need, OFDMA can actually, let's say, imagine that they can actually occupy this whole resource, to satisfy your need. So let's say if this is the whole resource is occupied, it's actually 3 times faster than FDMA. And because of this, if you are not using your mobile phone, OFDMA won't assign you any slots over here. So like what I mentioned, for example, if I have a heavy user, I can occupy this whole band here, to transmit or receive my data. So if I'm not using, I will not even appear on this OFDMA here. So over here, you can see a very quick comparison between 1G, 2G, and also 4G. Sorry for the mistake here. So basically it's 1G versus 2G versus 4G. 1G here, 2G here, and 4G. So therefore, you can see that why OFDMA is a very effective way, because not only just one frequency band, they actually can utilize lots of frequency and also the time slot for us to receive the message. So this really give you some idea about OFDMA. So basically, I will do another video to discuss about OFDMA. But I just want to explain in a very simple layman term so that you will be able to understand this OFDMA. So last but not least, let's quickly move on into 5G. 5G is a wireless technology with a limited rollout that intends to improve on 4G. So what is the idea of 5G? So basically, the 5G basically want to promise a lot of changes. Basically, the key idea, again, we guys actually ask for more data. We want to see whatever thing instantly. We don't want to wait. So therefore, 5G actually promise faster data rate, which means that they reduce our delay of receiving the message. So for example, if we want to receive a movie, it can almost instantly play the movie without any lagging. So but for 4G, probably there's some lagging, or maybe when you actually press the download for the movie, it will still take some time, but for 5G, it's almost instantly. So basically, this is some of the several promise from 5G. So they are going to have higher connection density, which means that there are more devices able to connect to the base station. As we born into the era, everybody nowadays hold not only one mobile phone, we have iPad, we have lots of other communication devices that will be connecting to the so-called base station. So therefore, the era of 5G, they also need to promise more connection, or higher connection density. We also want to have lower latency. Why we need to have this lower latency is even vehicle nowadays or autonomous vehicle. Imagine this, your vehicle come to a cross junction, whether you want to turn left, turn right, or go straight. okay, you need to have some process. Imagine if you fetch something from for so-called the server, okay, it take a few seconds. Then you will stop at that particular junction for a few seconds to consider to turn left, go straight, or turn right. So basically, this is not allowed. So basically, we have a latency. So 5G latency is about millisecond. Okay, so basically, instantly, they will execute either turn left, go straight, or turn right. So basically, this is the idea of having lower latency. Okay, they also promise to reduce our power consumption, okay, which means that the battery lifetime will be much, much better. Okay, so 4G, you know that when you actually do lots of activity on 4G, the battery can drain very drastically. So basically, these are all the few things that 5G actually promise. Okay, the theoretical speeds of 5G connection is up to 20 or maybe 10 gigabits per second. Okay, so but again, these are all the very theory thing that they promise. Okay, so I'm not going to so-called justify how they actually do this. But you know that in a reality practical world, or even 10 gigabits per second, I think is still a big challenge. Maybe I should say that. Okay, so how does 5G actually come into this spatial division multiple access? Okay, so let me share with this now. Okay, so what is this spatial division multiple access? Basically, they focusing several signal bin using advanced antenna technology, which is also called phasor array technology. Okay, so imagine this is a satellite. So basically, they use technologies like, for example, phasor array. Okay, they beams all the different so-called beams to serve the different user. Okay, basically, this technology mainly are used in satellite and cellular. Okay, so cellular is basically for 5G. Okay, so on 5G, they actually have this so-called, they stir the beam to serve a particular user. So with this, they can actually reuse the frequency, okay, focusing on different area. Okay, so you can see that basically this SDMA, let's say using a satellite, okay, you can imagine this is a place in USA, for example. Okay, and then you can see that because USA and Singapore, let's say they are very far away. Okay, so there won't be any interference on the so-called the phasor array. So therefore, we can actually share the resource, for example. Okay, so this is the meaning. Okay, but I don't want to discuss more on this SDMA. Like what I mentioned, I have actually a video on this multiple access. Take a look on that video to understand more on this SDMA. But I want to quickly discuss how this evolved onto 5G. Okay, 5G, the base station, okay, instead of omnidirection, okay, they become a facial array. Okay, over here you can see that for 5G base station, okay, they actually emit up a ray. Okay, just this bin here, they basically just serve one of the user. Can you imagine this? So basically, this is an era. So basically, so-called they have a very smart stir, okay, which control the array. Basically, the array, one array, for example, for this case here, is purely to serve this user. So once this user moving around this area, okay, this bin will actually follow him and serve him accordingly. Okay, so basically, this is the idea on 5G, how they actually use this SDMA. So in short, okay, how to have an effective resource. Basically, the base station, they have this spatial array. They stir the bean smartly just to serve particular user because this bean is serving you, just you. Okay, so you can guarantee a very high throughput. You can also guarantee a much lesser, so-called lesser latency, etc. Because purely, can you imagine just like you are in a dinner, okay, you have just one waiter serving you. Okay, so everything will be guaranteed, even the service. Okay, you actually can guarantee all kinds of service. Okay, so this is basically some idea about SDMA for 5G, although it's not really the whole of this multiple access, but this give you some idea. Okay, so basically for 5G, they also adopt this spatial division multiple access. Basically, they stir this bin to serve a particular user. Okay, so last but not least, I put all these different 1G, 2G, 3G, 4G, and 5G, okay, to conclude my discussion on the different cellular technology from 1G to 5G, and also the different multiple access that is utilized based on 1G all the way to 5G. Okay, with this, I'd like to end my discussion. Please help to like and subscribe. Once again, sincere thanks for your strong support. See you guys.